Well, welcome. Again, my name is Mr. Murphy, and in this video we're going to be doing learn some more properties of logarithms and how to apply those properties to some real-life scenarios. And so let's go ahead and let's start with a warm-up problem. So I want you guys to go ahead. So this deals with what we did yesterday in day one, and this is also going to help with what we're going to work on here in just a minute in the first example. So go ahead, pause the video, and work this one out, and then we're expanding this out. So again, we're using those properties that we learned about to be able to expand that out, and you might even have to do some simplifying. So after expanded, I want you to simplify anything that you can. All right, let's see how you did. So the first step, as you should recognize, is since we have 1 divided by x, we can pull that apart as two separate logarithms to be the log of 1 minus the log of x. Now, hopefully from earlier in this chapter, you also recognize the log of 1 is 0. And 0 minus the log of x would just be the negative log of x. So that's important to remember, that anytime we can simplify, you do want to simplify. All right, so let's look at this first example. So we're going to be applying some of those properties that we already learned about in day one. So here it says the pH of a solution is a measure of its concentration of hydrogen ions. This concentration, measured in moles per liter, is written H+, and is given by that formula where the pH is equal to the log of 1 divided by H+. What is the concentration of hydrogen ions in the acid rainfall? Okay, so here we have, in this diagram, we have 4 different scenarios. They gave us the pH of orange juice is 3, the pH of acid rain is 4.5, the pH of clear rain is 5.6, and a healthy lake, the pH is 6.5. Okay, so the orange juice is most acidic, versus a healthy lake that is least acidic, and so that has a higher pH value. All right, so we want to figure out what's the concentration of hydrogen ions in acid rainfall. Okay, so here's what we're going to do. The first step is we're going to substitute what we know the pH value to be. So the pH is 4.5 into that equation, okay, the one that they gave us in the story problem. And now we're going to solve this. So the first thing I recognize is we could take and pull that, what's on the right side, we could pull that apart and write that as two separate logarithms. So we'd have the log of 1 minus the log of H+. Now, that's why we did that warm-up. So in that warm-up, we learned that log of 1 is 0. So 0 minus that would just be negative log of H+. Now, I want to isolate the logarithm. I want to get the logarithm by itself. So I'm going to multiply both sides by a negative, or change that negative 4.5 and the other side to be positive. And now we can rewrite this. Okay, right now it's in logarithm form and there's nothing I can do. So now we want to convert this from logarithm form to exponential form. So to convert that in exponential form, remember we would say that the base for our logarithm is 10, and that's going to be the base when we write something in exponential form, would be 10. And remember what logarithms are equal to our exponents, and so our exponent would be negative 4.5 for that base. So 10 to the negative 4.5 power would equal the value, which is at H+. So that is your answer. So the concentration of hydrogen ions in the acid rainfall, we would represent as 10 to the negative 4.5 power. That's your answer. All right, I want you guys to try one on your own. Same exact problem, except for this time, if you read that last paragraph, it says, what is the concentration of hydrogen ions in, so it should say, in a liter of orange juice? Okay, so in 1 liter of orange juice, we know that the pH is 3. So I want you guys to use that information, just like we did in the previous problem. Follow the same steps as we did in the previous problem. So go ahead and try this one on your own. So hit pause, hit play when you're ready to check to see if you did it correct. All right, let's see how you did. So your first step, you'd put 3 in that equation just like we did earlier. So we'd have 3 equals the log of 1 divided by H+. Pull that right side apart, so it'd be the log of 1 minus the log of H+. Log of 1, remember, is 0, so we'd have 0 minus that, or just negative log of H+. Change that to be a positive, so it'd be negative 3 equals log of H+. And then finally, write your answer, get your answer, what's above here, as 10 to the negative 3rd power equals H+. So hopefully that made sense. And if not, make sure that you go back to that first example and re-watch that first example so you can see those individual steps explained a little further. All right. Our first formula or property that we're going to learn about today. I didn't highlight this, but please make sure that you write this down in your notes. So it's really important to get that logarithm. What's in the top of that box there, the log base b of m equals log base a of m divided by log base a of b. Okay, now you might be wondering, where does that a come from? You'll see, it really doesn't. Don't freak out about that base there in a minute. We'll explain that more. But otherwise, if you look at that example, log base 5 of 7 is equal to log of 7 divided by log of 5. It's that simple. Okay, it's really that simple. Or here's another example. If we have log base 2 of 3, again, we're going to put this in terms of common base 10 logarithms. You might be wondering, what's the whole purpose of this formula, by the way? When you're using like a scientific calculator or you're using your TI-84, and if you hit the log button, you can't change the base. So this allows you to be able to do things on your calculator when the base is not 10. So here we have a base 2. And if I wanted to figure out what log base 2 of 3 is on my calculator, I need to use this change of base theorem. And so here's how that would work. You would just literally write this as, now personally I would just skip to the end and write this as a log of 3 over the log of 2. But the step in the middle is explaining why we can do that. And so you'd have a log, your a, so notice in that formula we have log base a of m. Your a is your base. In this case our base is going to be 10. But remember, log with the base 10 is the same as log. So I would just write it as the log of our value, the log of 3, divided by the log of our base, which was 2, so log of 2. And that's it. I want you guys to try one on your own. So I want you to try both of these, log base 2 of 7 and log base 5 of 3. It won't take you very long, but why don't you pause the video and hit play when you're ready to check to see if you've done those correctly. All right, let's see how you did. So the first one, you should have just taken, literally, log of 7 divided by log of 2. Easy. The second one, you'd have log of 3 divided by log of 5. Now, if you actually wanted to find those values, now you could just type that in your calculator using the log button, log 7 divided by log 2. Bam, you'll get your answer. And that's where we're actually going to use this. Okay, so here, let's see how we can use that change of base formula to solve this equation. So this equation we have 2x, or 2 to the x power equals 7. All right. Right now, there's nothing I can do with it. The base, the 2 is by itself. Okay. If I had like 4 times 2 to the x power equals 7, then I'd want to get the 2 to the x by itself. But our base is by itself. It's isolated already. So next, we're going to rewrite it in logarithm form. So remember, our base is 2. So that's going to be our base for our logarithm. And our value, what 2 to the x equals, is 7. And that's going to be the value we take the logarithm of. And remember, logarithms are always equal to exponents. And so your exponent is x. So you could say x equals log base 2 of 7. If you had log base 2 of 7 equals x, same thing. All right, so now what? Okay, we have it like this. How do I figure out what log base 2 of 7 is? So we want to use that change of base formula. So to use that change of base formula, it'd be the log of 7 divided by the log of 2 equals x. And now I can type that in my calculator. If you type that in a calculator, you get approximately, you're going to get a huge decimal, but chances are on Pearson or in your quiz and on your test, we'll tell you what to round to. And so in this case, we'd round to 3 numbers past our decimal, or the thousandths place. So we'd have 2.807 as your final answer. All right, so how'd you do? So I want you guys to try this one on your own. So you have an opportunity to see if you can do this one independently. So all we're doing is following the same process, this time for 3 to the x power equals 15. So you guys can go ahead and, write that problem down. And then I want you guys to try that one on your own. So go ahead and pause the video and hit play when you're ready to check to see if you've done it correctly. All right, let's see how you did. Now I can show you the answer. So we have 3 to the x power equals 15. So again, you just start by rewriting the equation. And we already have the base by itself. Again, I want to emphasize if the base is not by itself. If we had 3 to the x power minus 8, we'd have to add 8 to both sides. Because your first step, before we change from exponential form to logarithm form, or vice versa, you want to make sure that you, in this case, that you have the base by itself, which we do. So then we're going to change it to logarithm form. So to change the logarithm form, again, your base is 3, your exponent is x, your value is 15. So our base for our logarithm will be 3. Our value for our logarithm is the 15. What it's equal is your exponent, which is x. We'd have x equals log base 3 of 15. But your calculators probably can't do that. So to do this on your calculator, you have to use a change of base formula. So then we rewrite that as log of 15 divided by log of 3. And now you can type that in your calculator, and you get approximately 2.465 as your answer. That's it. Hopefully you guys did well. Hopefully you guys got that. I think that's a little bit easier than using some of those other properties that we learned about yesterday. Speaking of other properties that we learned about yesterday, why don't you go ahead and pause this, and in fact, let me make myself transparent again. So now you can see this entire sheet. So why don't you guys make sure that you have all this information in your notes? This is all the key things. I would make sure you have this in one spot. So even if you already have this in your notes, maybe create like a formula sheet or a cheat sheet that you can access quickly and easily when you go to take the quiz and on the test. But make sure you have at least those formulas. If you don't want to take the time to write down what it is in words, that's totally fine. Or if you don't want to write down the examples, that's fine. But I would definitely make sure that you know what each of those properties are, because these are all very important to know how to use and when to use them.